Well, hello again, and I'm going to record in this session the notes for section 12.4 and 12.8. Section 12.4 is called MACRS Depreciation. That stands for Modified Accelerated Cost Recovery System. That's basically a depreciation system that was written into the tax law of 1986 and has not been changed, and it's the most commonly used depreciation system currently in use today. And then depletion is something that deals with not personal property and real property so much as natural resources. Things like oil and gas, coal, gold mines, silver mines, things like that are natural resources. Timber, forest lands, they're natural resources. And if you use those as part of your business, in other words, you own a coal mine or you own a forest that you're going to make wood out of, lumber out of, then those things are depletable assets or natural resources that you can deplete. And the reason for that term is just that depreciation refers to the wear and tear of generally things that are replaceable. A building can be torn down and build a new one, or a machine you can buy a new machine. These resources are generally not replenishable by just going out and buying another one. To some extent you can, because you can always just buy a different forest, I guess, different forest lands. The bottom line is section 12.4 is covered in pages 366 to 369. 12.8 is 376 to 379. You should read those pages. And I'll skip all of the stuff that we always talk about with every lecture, since this is a second half of really a lecture. So section 12.4 deals with Modified Accelerated Cost Recovery System, MACRS Depreciation. As I mentioned, came in with the 1986 tax reform law, and it's very taxpayer friendly. Okay, so that means that taxpayers want to use this system, so it's the most commonly used system, and it's the simplest system to use. It's much simpler even than straight line and declining balance that we studied in the previous video. So we're going to talk about this system is dependent on depreciation rates and dependent on knowing the recovery period for an asset. So we'll talk about those things here. But equation 12.10 basically says that the depreciation in year T under the MACRS system is little d sub t times the basis. That's the depreciation rate for that year times the basis. Well, where do we get this depreciation rate? Remember, in the straight line and in the declining balance, we had to calculate a formula to get it. Now we just look it up in the table. So if I'm dealing with 3-year property, I go to table 12 for n equal 3. If I'm dealing with 10-year property, I go to table 12.2 to the n equal 10 column. And then these are the little d sub t's expressed as a percentage. Of course, that number there has to be a decimal. So, for example, if I was looking for how much is the depreciation in year 5 for 10-year property, I would take the basis and multiply it times 0.09222, 0.0922, which is 9.22% of the basis. That would be my depreciation. And then the book value is the previous year's book value, B sub T, is, or the book value in year T is the previous year's book value, B sub T minus 1, minus the depreciation I take in year T. So I'd have to calculate that year by year, because these factors, these numbers here, these little d sub t's are changing every year. And so another way to calculate the book value at the end of year T is just take the original basis minus all the depreciation you've taken, including the year T depreciation. So it would be the sum j equals 1 to j equals t of d sub t. That's the total depreciation taken so far, minus subtracted from the original basis. And so these, this table I would give you on the final exam. It'll be part of the final exam. So you don't have to memorize any of this. And I would tell you how many year property it is. So notice also that, for example, 3-year property is depreciated over 4 years, because this table is built on what's called the half-year convention. I mentioned that earlier in the definitions, but the half-year convention means basically you would get half of some rate the first year, because it could have been put in service in January or December, so they just kind of split the difference and say, we'll give you half a year's depreciation the first year, and then you get to take the remaining half year in the n plus first year. So 3-year property is depreciated over 4 years under MACRS, 5-year property over 6 years, 7-year property over 8 years, and so on, n plus 1 years. So the author summarizes some of the depreciation formulas that we've already discussed, all of these and the ones in the previous sections, in table 12.7. And I'll just, I repeated that table right out of the book here in these lecture notes. And the author compares the MACRS depreciation with the straight line with the double rate declining balance. And he says the fixed depreciation rate D sub T, nope, in MACRS it varies. You just have to look it up in this table, okay? I could give you a formula for it, but it's complicated. So, but in straight line, it's just 1 over n, right? It's 1 over n times the price minus the salvage value. With double rate declining balance, it's 2 over n, but we don't ever estimate the salvage value. It's just 2 over n times the basis, b. Here it's b minus s, but here it's just b. The annual depreciation, d sub t, you have to look it up in the table. Here it's 1 over n times price minus salvage value, and here you multiply this factor times the basis to get the depreciation in year t. Basically, that's one of our equations back in lecture 24a, the previous lecture. And then the annual depreciation, d sub t, is always little d sub t times b. In this case, it's b minus s over n. Here it's this times the original basis, okay, b. And so on. Book value is you can get by these numbers. So the last method we're going to talk about in chapter 12 is called depletion. Depletion refers to the using up of a natural resource, as I mentioned, and so there's 2 common methods of depletion. The more popular or more method is probably the percentage method when it's allowed by the tax law, and that says that the percentage depletion allowance in year T equals the percentage rate for that particular type of asset. We'll look at that in a little bit later. but it varies by what kind of an asset it is, or I said asset, but it's a natural resource, times the gross income in year T. So in this case, notice that that depletion is not a function of what you paid for the asset. It's how much gross income the asset produces. That's a pretty significant factor. That means theoretically you could take over the life of the asset, say a coal mine or whatever, a gold mine, you could take more than what you paid for it in depletion allowances. In certain cases, you'd have to have probably a tax lawyer to figure it all out for you, but and big companies have lots of them. So let's look at an example. This is example 12.7 problem in the back of the book, I guess. A gold mine with the original cost $10 million. So that's our P. That's also our basis B. The gross income is $8 million a year, and that should be ION. In years 1 through 5, and then $5 million in years 6 through 15. What is the depletion allowance in each year? This is a little bit different, by the way, than the example 12.7 in the book. It's very similar, but I changed some things because I wanted to emphasize some other things than what the author had. What is the depletion allowance in each year? Okay, from the table below, we'll get the percentage for gold is 15%. Well, let's look at this table below. This table is in your book, by the way. And this table says a sulfur, uranium, lead, nickel, zinc, and some other ores, those minerals, those natural resources, they get a 22% depletion rate. Gold, silver, copper, some oil shale gets 15%. Oil, natural gas wells get 15%. Coal, lignite, sodium chloride gets 10. Gravel and sand get only 5. And most minerals and metal ores get 14. So those are just things that the Internal Revenue Service has defined as allowable, okay? So we first would get, then this particular problem is dealing with a gold mine, and we just saw that gold is 15% percentage rate. So we're going to be able to use 15% of the gross income as our depletion allowance in the year that we make that gross income. And this particular problem said we had $8 million a year for years 1 through 5, $5 million a year for years 6 through 15. So we start depleting this asset. In the depletion in year T is 15% of 8 million for T equals 1 through 5. So that's 1.2 million. And then in years 6 through 15, there's 10 more years, it's 15% of 5 million, because that was the gross income. And that's 750,000 a year for years T 6 through 15. So let's look at our total depletion taken through year 15. And maybe there's additional years that this is going to produce income, but at least through years 15, this 5 years at 1.2 million a year is 6 million. 10 years at 0.75 million a year is 7.5 million. We've depleted $13.5 million over 15 years, but the thing only cost $10 million. That's the advantage of depletion, the percentage method, that is. Now, if you use the other method, which is called the cost method, you're limited. You couldn't deplete any more than $10 million, because that's what the asset costs. So That's what I'm stating here in this red note. This is the table we just used. Then I want to talk about equation 12.19 or 1219 is used to obtain the cost depletion factor. That's the other method. This one, 1218, is the percentage method. 1219 is the cost method, cost depletion factor. In that case, you take the first cost of the asset, which in the previous example would have been 10 million, and you divide it by the estimated capacity. So we would take that 10 million under the cost method, and we would have had to estimate how many, let's see, it's gold, how many ounces of gold are in this asset or this gold mine, and use that then as our cost factor. So here's an example. Forest land costs $700,000. So you go out and buy some rural land that has trees on it, okay? Is estimated to have 350 million board feet, MBF, of harvestable timber. The percentage depletion method is not permitted for timber, so we're going to have to use the cost method, and that's cost factor or cost depletion factor method. P sub T is called the cost depletion factor, equation 1219. So we calculate P sub T, and that's the original cost of the forest land divided by the number of million board feet that we estimated were there. So we end up getting that we paid $2,000 per million board feet for that natural resource, that timber basically. Now the question is, if 22 million board feet is harvested in year 2, and the cost depletion allowance, what is the cost depletion allowance in year 2? The cost depletion in year 2 is P sub T times 22 million board feet. Well, the P sub T is $2,000 per million board foot. That's 2,000 per MBF times 22 MBF, and that gives you $44,000. The MBFs cancel if you think about in terms of units. Okay. So I have other example problems here. Example problem 1. Let's see, how many do I have? I guess I just have 2 example problems. Del Norte Brick is located at the intersection of Texas and New Mexico and Mexico, and improved access to the property by way of a small privately owned bridge across the Rio Grande River. The bridge costs $770,000, and it has a recovery period of 15 years. Determine the depreciation and book value for year 3 according to MACRS method. Well, if we look this up, the depreciation in year 3 that we're looking for, the basis is $770,000. It's 15-year property, so from table 12.2, which will be provided on the final exam, D3, let's see if I can bring that up for you. This is 15-year property. We want to go down here to 3, is 8.55%. So D3 is 8.55%, or 0.0855. This value was obtained by looking down column N equal 15 and row T equals 3. Equation 1210 is used to obtain the depreciation in year 3. D sub 3 equals little d sub 3 times B, and D sub 3 equals little d sub 3, we got out of the table 0.0855. B was 770, gives you 65,835. The other part of the question was, what's the book value at the end of year 3? Well, to get the book value, we have to take the original basis and subtract the depreciation in year 1, 2, and 3. So I had to go back and calculate the depreciation in year 1 was 38,500. In year 2 is 73,150. In year 3 it's 65,000. We subtracted those three numbers from the original basis, and we get the book value at the end of year 3 to be $592,515. One more problem. Problem example 2, Aaron Pipeline has a service contract for part of a Black Mesa slurry coal pipeline in Arizona. Okay, this is coal, so we would have to look up what's the deal on coal. Well, let's see. We got to go to, this is a natural resource. Okay, so this is a coal. It's 10%. Okay, this is a section 12.8. This is a depletion problem. Oh no, it's not. Okay, depreciable property. Okay, I'm sorry. Scratch that. It's a pipeline. It's a slurry coal pipeline. It's not a coal mine. Okay, the pipeline is not a natural resource. It's actually, pipeline is real property, real estate. It's a structure. Calculate the MACRS depreciation and book value for each year if this property is 5-year recovery property. Okay, so we go to 5-year, and 5-year recovery. The first year we get 20%, the second year you get 32%, so on and so forth. So down through the 6th year. So we go to table 12.2, and the original basis is the $500,000. The book value times 0 is 0, and now we're going to create a table of depreciation and book value values. So this would be very easy to do. We start here with the book value at $500,000 at times 0. The depletion rate the first year, I just copied this column here out of this table, 20%, except these are percentages. I made them into decimals. 32%, 0.32, 19.2%, 0.192, and so on down the line. So then I multiply this quantity, this D sub T, times the original basis. Always go back to the original basis. So 20%, 500,000 is 100,000. Your book value then remaining after you take the 100,000 depreciation the first year is 400,000. And then the second year you get to depreciate 32% of the original basis. So that's 160,000. And then you take that 160,000 from the 400,000 book value, and leaves you with a 240,000 book value. And we keep going down the line. Notice that under the MACRS depreciation, we always end up with a book value of 0 at the end of year n+1. Because if you look at these percentages, they always add up to 100% if you added all these columns. So the bottom line is that's how you do MACRS depreciation. I did not have an extra example on depletion, but there are examples in the lecture notes. So look those over again, and we'll see you next time. Thank you.